inequality sign, which means we need to just remember those basic rules of graphing an inequality. So you already have these, so we're going to make a quick shortcut here, right? If it's greater than or equal to, we are going to shade above. If it is less than or equal to, we are going to shade below. Greater than and less than tell us to use a dash line. Greater than or equal to and less than and equal to tell us to use a solid line.
Oh yeah, didn't we do this earlier?
Yeah, so this is exactly those same rules that we put when we were graphing with inequalities. Okay, and we already know how to graph an inequality. Now we're just turning that into a system of inequalities. That's why it's not really anything new today. We're taking that concept that we now know about solving systems by graphing, and the concept that we already know about how we graph an inequality, and we're putting them together into systems of inequalities. Okay, now these rules, remember, they only worked if we were solved for y. So we're going to want to make sure that we have it solved for y before we do anything else. Now, we need to do a little bit of rewinding, because remember I said today we're not really learning anything new, but we have to make sure we really remember those concepts that we've already talked about. So when we look at an equation and we solve an equation and we get an answer like x equals 2, what does an answer like x equals 2 mean? What does that mean? What does that tell us?
That x equals 2.
What does x equals 2 mean?
That x equals 2.
That's undefined.
It's verb. No.
So if we have an equation like 5 plus x equals 7.
Oh, no, that would.
What does x equaling 2 tell us?
That's a slope.
No.
X1 go over 2.
We're thinking too much about graphing. I'm not asking you about graphing. I'm asking you about solving and x equaling 2.
X equals 2 is like, say, it would be 0 because you can't. It's saying that there's only one like point on the 0.
There's one solution.
Yeah.
There's one solution. We do know that. And what is the one solution?
X equals 2.
X equals 2. And what does that 2 mean?
2 is equals to x.
What can we do with that 2 if x equals 2?
Plot it on the 0.
Now you're thinking graphing, not graphing.
Put the line.
Don't think anything about graphing. Just think about this equation.
Solve it.
You told me that x could be one value. What is the one value x can be? 2.
I'll see plug it in.
And what happens if I plug it in?
That's being 2. X.
Is this true? Does 5 plus 2 equal 7?
Yeah.
Yes, so there is one value that if I replace x with, it will give me a true statement for that equation. Because solutions are always things that make the equation true to start with. Okay, so what if I say x is greater than 2? How many solutions does that have?
1.
More than 1.
Many.
More than 2.
Many.
Infinite. How many numbers are greater than 2? Infinite, right? 3, 4, 5, 6, 7, right? It's not all solutions. Because if my answer is x is greater than 2, is 0 a solution?
No.
Is negative 5 a solution?
No.
No. But there are so many solutions that we can't write them all down. Okay, so we said instead of writing them all down, we could represent them by graphing. And we went here. And we said it would be an open circle shaded to the right. What does that open circle mean?
It's a.
It can't be 2. Because what is the first number larger than 2? 2.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000. 0, 0, 0, 0, 0. How long can I say zeros? For forever, until I put a 1 on the end, right? We can't actually write down the number that is closest to 2. So instead we put this open circle to represent that we can get as close to 2 as we want. We just can't actually stand on it. Okay, so that was the same idea that we then talked about here. The dash line meant we could get as close to that line as we wanted. We just couldn't actually stand on it. Okay, so now instead of one solution, we were talking about an infinite number of solutions, and we were just representing that border that we could get close to. Okay, those pieces are going to be crucial today that we remember them. So now when we look at this table and we talk about the types of answers we can get, our answers are going to look very different than they did when we had equations. Our lines will still be the same idea. Okay, so we can still graph two lines, and we can either get lines that intersect, lines that are parallel, or lines that are the same line. Okay, because we're still going to be graphing those two lines, but now instead of talking about like this point where they intersect, right, inequalities allow for like a space, an area. We have way more happening in that solution set. So we're going to have to take that into consideration today. So now when they intersect, instead of there being an intersection point, okay, there is going to be an intersecting area. Right? So instead of one solution, we're moving to infinite many solutions, just like we did with equations to inequalities. Okay, so if we get something that overlaps, if we get intersecting lines, we're going to have an infinite number of solutions.
Can we put IMS?
It's going to be a little bit different than that. And what it's going to be, the infinite solutions, is going to be the overlapping area. So it's actually just going to be a picture today for the most part. Which hopefully makes sense to us, because as we've been looking at inequalities, whether we're talking on a number line, whether we're talking on a coordinate plane, where we've always said that there's really no way to write down the solutions, so we just represent them with a picture. Whether that picture was a number line or whether that picture is on the coordinate plane, it's still just a picture. Okay, so we won't get that final solution of like 4, 9 today. Here's where it starts to get messy. Because my students go, oh, well, sweet, if we get parallel lines, then, I mean, it's still just a no solution is a no solution. Well, that's not exactly the case today. If we get parallel lines, it might be a no solution, but it might also still be an infinite area.
What does infinite area mean?
You'll see in just a second if you're struggling with that concept. I'll show you here, Caleb, okay? And if that wasn't complicated enough, if they're the same line, come on, how much can they be if we actually get the same line? Well, it could be the same line. It could be the actual line. I don't need to write down same. Okay, the answer could be the line. The answer could be a no solution, or the answer could be an infinite area.
That's 3 choices.
It sure is. My students start going, oh my gosh, how am I supposed to decide? This is where the understanding comes into play. Today we need to really truly understand what we're doing to know which type of answer we're going to want or need. And it all comes down to the idea that a system solution is where both the equations are true at the same time. Where do they overlap? Right? So here's how this is going to work. We have a system because we have 2 variables, 2 equations, 2 inequalities. And just like we did yesterday, we're going to graph both of them on the coordinate plane at the same time. Now, this stuff down here won't be on your test. I'm giving you this here just to help you think it through right now. Go, Gillen.
How do you do the less than or equal to?
So here's what we're gonna do. We're gonna start with one of them. Okay, so pick a color for your first equation. I would choose a light color. We don't want to make it too dark. If you're just gonna use one utensil, just make sure you're not writing too darkly with it. Okay, so y is less than 4x plus 2. What does m equal?
4x.
Just 4, right? We don't need to write down the
Oh, yeah.
x.
And then 2.
B is 2. Okay, so that's just like normal. Now we need to interpret our shading above and our shading below. Okay, so we're going to look at our inequality symbol. If we use this symbol and we look at our little cheat sheet above, does this symbol tell us to make a solid line or a dashed line?
Solid. Oh, dash line.
Dashed. No solid line underneath. No solid line when we graph it.
Because the non-dash is the one that has the line under it.
Yes.
It's equal to.
Okay? Does this symbol tell us to shade above or does it tell us to shade below?
Above.
Below.
Less than
Oh,
is
yeah.
lower, less than is below. Okay? We okay with those pieces? So now we're just going to graph this inequality just like it was last unit. So I'm going to start at 2 on my y-axis. And what's my slope going to be?
4 for 1.
Okay, so up 4 over 1. Up 4 over 1. How many points are we going to make?
3.
More?
Over.
Yeah, we're going to make enough, right? Enough of them to get across the graph.
It will be 6.
Okay, because remember, this isn't necessarily dependent on a nice intersection point, but it is going to still be dependent on a nice line. So we're going to want to make sure that we're graphing well enough. Some very sleepy students today. Okay, so now we're going to create a dashed line.
I didn't do that one.
And we want to shade below. So remember last unit when I was saying don't shade too much, don't shade too little, it's going to be important later. Now is later. Okay, so we want to make sure that we're shading, this is too tiny. This is entirely too much. Right, so we want to get all the way up to the line and all the way across the graph without shading so dark that we can't see anything else. Yes, madam.
There's 2 equations up there.
Sure is.
Where's the other one?
We're going to have to put that on top of it. That's why I said these get very messy. We don't want to shade too dark because then we won't be able to see the stuff to graph another one on top of it.
Oh, we're on the second one now?
Nope, still I just finished the first one. Getting ready to start the second one. Okay, so now we're going to pick a different color if you choose to use a different color, and I'm going to go to the second one. Okay, so what does M equal?
So, which is 1/2.
Okay, what does B equal?
0.
0. Is this line going to be solid or dashed? Solid. And are we going to shade above or below?
Above.
Below.
This is a below, this is a less than is lower. Okay, so now we have to ignore that the first stuff was ever there. We're ignoring it altogether. So I'm going to start at 0, and now I'm going to go up 1 over 2, ignoring the yellow altogether. That's why I don't want my yellow to be too dark, because I need to be able to keep going. I got to ignore that it's even there. Yep, this one then has a solid line. Okay, so this one is below. So we need to ignore the yellow altogether. So I'm just looking at my orange line, and I'm shading everywhere below up to the line across the graph. Right on top of where I already had shading. And if you're looking at it going, this is really messy, yes it is. Because we're still not done. We've got more to put on here. Yeah. Just making sure we get these both graphed. Got these pieces down. Yep, looks good. Yeah. So here, just keep going with this. See these points? Do you need larger graphs for this? Can you see these? Kind of. Okay, so we get some larger graphs. Okay, so you're putting this solid line in here. Okay, and then we're shading below. So we have all this shading here. Does that help? Mm-hmm. Now, our objective is that we want to know where they are both true at the same time. So for both of them to be true at the same time, we would need to see both colors at the same time. So do we agree that like up in this area, they're definitely not both true because we don't have anything? Can we agree with that statement? So are there places that we do see both of them at the same time?
Yeah.
Where?
Fourth quadrant.
Yeah, so past quadrant 4, but this sort of general area. So what we're going to have to do is now show that that's our final answer by shading that in darker. So all of this area where we have yellow and orange both happening, this area is our final answer because yellow and orange both happen there. I did it with a different color, but you can just shade it in darker. Or whatever you want to do. Whatever works for you. Okay, so do you see how right here you see red and blue? So all of this, even over here, right, all of this gets shaded in darker because that's your final answer. Now, this is actually your answer. Okay, this is what you would give me. And Chloe's face is like, what in the world, right? I mean, exactly. That's what we're all thinking, right? What in the world, Mrs. McKinney? This looks stupid. I don't understand what's going on. Let's see if we can actually interpret this. Let's talk about what this means. This is the understanding piece that's important. Is this, you don't need to write this down on your paper. You can just look up here. Let's use your brains. Is this an answer to the system of inequalities?
No.
Why not?
Because that added to the other graphs. Or that.
Right, so we're sitting that over here.
It's not on that line.
Does it have to be on the line? Is this an answer
Yes.
to the system?
Yeah.
Yes.
Why?
Because it's in that area where they
Right? It's in that area.
Okay.
Is this an answer?
Yeah.
Yes.
Yeah.
It's just extended.
Yes, because that shading would continue down. Excellent. Okay. Is this an answer?
Yes.
Yes.
No.
Yes.
On the line.
It's on the line, so it'll
But it's on the other line,
it'll
so
still be an answer.
No, because it's not. I don't think it's an answer.
Is this an answer?
No.
yes.
No.
I'm confused.
Yes, it is. It's still an answer.
It is.
Because it's in those 9 points.
Okay, so let's go in reverse here for a moment. Let's say, again, you don't have to write this down. I'm just writing something down here. I'm going to graph this inequality just like we did last unit. I'm going to give this a dashed line. And I'm going to shade above. Okay, so if I gave you this, is this an answer?
Yes.
Yes, it's in the shaded area. Is this an answer?
No.
No.
No, it's not in the shaded area. Is this an answer?
Yes.
It's on the line, so
It's on the line.
It's on the line. It is.
Okay, let's go in reverse a little bit further.
Oh no.
Is this an answer?
Um,
Yes.
Yeah.
Is this an answer?
No.
No. Is this an answer?
No.
No.
No, because
Yeah.
it doesn't have the line under.
Oh, but if it was
Because
close
it's
to-
not or equal to, right? So if I
But
did
if it was
this,
equal to, yes, it will.
then it is an answer,
Oh yeah.
right? That is the difference of the dash and the solid line. So I hear the mind starting to change. So is this an answer?
No.
Why not?
Open.
Because it's an open line, right? It's a dashed line.
But
Is this an answer?
Yes.
No, it's not.
No.
Yes,
Why
it
not?
Because it's a
It
dash.
is.
Because it's dashed. Is this an answer?
Yes.
Yes, because it's solid. Right? So the borders of that area, it depends on if we have a dashed or solid line. The dashed line says yes, it does count. Come on, Isaac. The dashed line says no, it doesn't count. Because a dashed line says you can get as close to it as you want, but you can't count it. A solid line says you can get as close as you want, and you can count it. Are we okay on that?
Yep.
Next problem. Okay, so we're going to start with the first inequality. 2y is less than or equal to 6x minus 8. What are we going to have to do first?
Find the slope.
Solve it for y.
Oh. Why?
Right, because the rule says for us to just use that shading above, shading below, we have to be solved for y. So that's why we're doing that first. Isaac, come on. Put the paper over. Next problem. What does m equal?
3, yeah. 3.
Just 3, right? What does b equal?
4. Negative 4.
Solid or dashed?
Solid.
Above or below?
Below.
Okay, you start graphing it. I'm going to start graphing it too. We're going to start at negative 4 on the y. Solid. Below. What are we going to do on the second equation?
Solve for y.
Solve for y. Y. Okay, so let's make sure we're remembering all our info here. What happens now?
Y and then flip the sign.
We have to flip the sign because we divided by a negative 3. Now, we can't get too excited and go, ooh, these are the same m and b, so I just have an answer. Because if we have the same m and b and we get the same line, that meant there was 3 choices for us to pick from. It was actually more difficult if we have the same line. So we really have to make sure we keep going and see what happens. So this is going to be a dash line. And we're going to shade above. Now, I can graph directly on top of with my Promethean board. I realize you can't do that, especially if you're using the same color. So if you need to like go right next to it to see what you're actually doing, I won't count you off for that. Okay, I understand that it's not always easy to make those points right on top of it. If you need to go next to so that you can interpret it or something, I'm fine with that. Just don't like make it way over here. That's too far away.
So how would we do it?
Like if you need to just like make your dash line like right here, right next to it, like right to,
Can we do dashes like this way?
sure, whatever sort of helps you see, that's fine. Okay, so then remember, we are looking for an option where we have them overlapping. So they both happen at the same time. Where do pink and green happen at the same time up here?
Never.
Why did you say never, Sam? What do you mean it doesn't?
They don't touch each other.
I mean, the line is the same. They both create the same line.
They're on different sides. One's dashed.
But one's dashed.
Yeah, one's dashed and one's.
What does it mean if one's dashed?
One's open and one's closed.
Is the line actually there when it's dashed?
No.
No. So are they both actually happening there at the same time?
No.
So is there any place that these overlap?
No.
No. So what's our answer?
No solution.
No solution. This one is a no solution. And you have to write down that no solution. Now, again, this is that piece where one minor detail makes a large difference. All that would have to happen is this have an or equal to, and then they would both be solid lines, and the answer would be the line.
Wait, so would you like say the line in a different color then, or would you write the line?
Yeah, that one is a tricky one. My students have asked me before. You can either make the line thicker, you can just say it's the line. Sometimes my students will even like draw an arrow to the area because their picture gets so messy they can't really. As long as I know what you're talking about and you make it clear to me, I'm fine with that. Okay. So moving right along, next one. I left off them and B here, right? Because we have one of them that's an x equals, and hopefully we know these rules by now. So x is less than 5, solid or dashed?
Yeah.
Above or below?
Above.
Below.
Less than is lower. How do we graph x equals 5?
It's on the zero. It's gonna be on the x-axis.
X-axis at 5, and then which direction?
Horizontal. Or vertical.
Up and down, which is vertical. So this is a dashed vertical,
Which is undefined.
right? Which has undefined slope. Which way am I going to shade? What is below for this line?
It's gonna be on the negative side.
On the right to the
So on
left. All the way across the graph, up to the line.
And then when y, it's gonna be dashed still, but it's gonna be above.
Yeah.
It's gonna be on the y-axis.
So you see how this doesn't really require a lot of new information. It's just really looking at this mess very carefully.
I have a quick. I get confused with this sometimes. So if this y is greater than 2, is it still gonna be like 5 was up and down, or is it gonna be like this?
Mm-hmm. Above the orange. So what's our answer gonna be?
The top.
Yeah, right. The sort of top left area up here.
This is the first quadrant.
I know we can't really talk about quadrants in this area. I mean, we're mostly in quadrant 2, but we're not in a quadrant. Yes.
So do we shade the whole top or like just the left?
You're
or-
bounded by these lines. So our pink and orange line are where we're stopping. Can you see your lines on yours? Can you tell? Yeah, so do you see your blue line right here and your red line right here? So see how this is only blue
Yeah.
and this is only red? But right in here we see red and blue. That's our answer.
Alright.
Okay, so let's go back to sort of this concept that we were talking about. Is this a solution?
No.
Nope. Is this a solution?
Yes.
Yes.
Yep. Is this a solution?
No.
Yes.
That was a yes and no.
No.
Why not?
Oh no, because it's not in the.
It's a dash line.
Yeah.
Yeah,
Oh,
James.
sorry.
So that's just how they.
My bad.
Well, I've just sent people to the ER getting stitches because they fall out of their chairs.
My bad.
Just makes me nervous.
Yeah, I don't want no more stick.
Okay, so dash line is a no solution.
Mm-hmm.
Okay.
So that's the answer?
Are we? Right. So your answer is just this picture because we have a shaded air gap.
So no solution?
No, it has a solution.
Oh.
That's the any place in here is an answer. How many answers are there?
Infinite.
Infinite, right? I could make a bajillion points. And then more?
Mm-hmm.
That's a problem. What do we have to do first?
Solve it.
Solve it for y. So you start solving them for y. I'm going to too. You just keep going and you can check up here to follow and make sure you're doing okay.
Oh, yeah.
How is it a negative one?
Because I have to solve it for y.
Oh, I didn't use that.
Yeah, you have to solve for y before those rules will work.
So when we go down 1 over 1?
Yep, down one, right one.
Yeah.
Hmm?
Yeah, it's gonna take a while. I have a question. Why isn't it below for? Because I thought it's a negative.
Doesn't have
Oh,
to
is
do, has to
it
do with the
because we're
sign.
not
It's
dividing
greater than.
by a
Wait.
Right, I'm not dividing by a negative, so I don't flip the sign.
Okay.
Oh, I did the wrong one first.
Doesn't really matter which one you do first, as long as you do both of them.
Oh, well, I'm wrong.
Well, then that is a problem.
These are parallel.
Yeah. Why are they parallel?
Bec-
What makes them parallel?
They have this.
Oh, they have the same.
They have the same slope, right?
Yeah.
Parallel lines always have the same slope.
Mhm. You have to solve for y on this one too.
Yep.
There will be no solution
Why, Gabe?
because there's no intercept in any way.
Right? There's no place we ever see any overlapping.